All right, so welcome again to SciFM 24. My name is Karthik Durasamy. I direct MICD for those who were not here yesterday. And we had a great session yesterday, starting off with 3 talks in biology, drug discovery, materials, and we had a very engaging tutorial session. It was somewhat unstructured, and it was the first time we were trying to get this kind of material out to the community, and I think the feedback was also very important. So anyway, thank you for engaging. And my favorite part was the office hour discussion where we kept going and going and going. And that part was really amazing. In any case, so I have about 20 minutes, and I want to spend about 5 or 6 minutes talking to you about MICD because this conference also doubles up as our annual conference, right? And there were a few people who were also asking me yesterday about how we are structured and things like that. So just bear with me for 5 minutes and we get into the normal material. Quick note on history. So scientific computing has been around at Michigan at least since 1946 in some form, if you count statistical research. But scientific computing per se started in about 1967. But one of the biggest moves that happened, the predecessor to MICDE, was the Laboratory for Scientific Computing, established in 1986 by Bill Martin, who's very well known to many people here. And one other major milestone was our PhD in Scientific Computing program, which started in 1988, and it's the oldest such program in the country. And the current version of MICDE started around 2013 and formed officially around 2015. And there are also sister institutes like MIDAS, ArcTS, et cetera as well. All right, so MICD's mission, as stated here, I'm not going to read it out, basically new paradigms and applications of computational science. But we are most excited about a future in which computations generate knowledge and not just inform decisions, right? It may drive decisions in the future, and we want to make that happen. So that's the vision. And if you go to our website, you can see every semester we release a magazine showing some snapshots of what's been happening in and around the community. So I'll just give you a couple of recent highlights, especially because quite a few, this is a SciFM conference and this is 2024, which means there are many people who are submitting their Gordon Bell submissions as we speak. So we are the home of the latest Gordon Bell Prize, so that was a big thing for us last year. We had a new NASA-funded Center of Excellence for space weather, and a whole range of NSF, DOE Early Career, AFOSR, NASA Early Career Awards, which we are very thrilled about. In addition to the educational program, which I'm going to talk about, and some of the research things that I showed, MICDE also catalyzes seed grants. So last year, for instance, we gave around 6 seed grants. These are $100K each, for faculty to propose projects in areas that maybe the outside funding environment is not quite ready for. And as example number 1, we funded an effort by Venkat, who spoke yesterday on foundation models for battery electrolyte design, and got some very good early results, got the Insight Award, and then we have a new initiative in that area. And there are quite a few others that are related to the topics that we're talking about today. A quick note about the PhD program. So currently we have about 152 students from, about 25 different departments. And if you see the impact of MICDE, so 2013 is roughly when the new version started germinating. 2015 is when we officially formed. And since then, I think the enrollment has grown by a factor of 10. So that's a testament to especially the previous director. So I've been in charge only for a year and a half, so I can't claim any of this. Probably the last slide on MICDE. So these are some of our strategic thrusts. So the pillars are methods, and then the horizontal bars denote some areas that we are application areas that we are pioneering at the present moment. Okay, and now a transition slide between the conference and what's been happening on campus. So as soon as ChatGPT hit the internet back in November 2022, we started organizing, we looked at the potential of generative AI and started organizing around these ideas as a campus. So we wrote a fairly well-referenced report. This is about 90 pages. It's out on this website. And I'll read to you some of the efforts that was recommended in the report, and I'll tell you, how we're going about it. So one of the first things we said was we want to embrace Gen AI, even though we know all of its flaws, all of its limitations, but we identify it's an emerging technology that we need to try and see what happens, and also try to manage its development. So as early as August of last year, the community, every student, staff, and faculty member at the University of Michigan has free access to what we call as UMGPT. This is basically built on ChatGPT, but it is custom in the sense that the data stays private, and it maybe trails GPT-4 by some months, but data is not sent back, and it's basically our own. It's hosted on basically the Azure cloud, but as a Michigan service. The second one, certainly connected to some of the discussions yesterday, we offer customizable generative AI tools. We call it UMAZY. So it's a code-free RAG. I think one of the applications is, faculty members can upload their lectures or their research materials and then use that instead of using the standard version of GPT. And in some interesting use cases, professors have uploaded their lecture notes, given Mazy access to the lecture notes, and then registered Mazy as a student in their classes, and then seeing how the AI student does compared to the normal student, and also getting feedback on how material is being ingested. So there's some interesting use cases.
How does it do?
Depends on the faculty member, the class, when they used it, etc. Last year, before this could read images and things like that, I think it was a mediocre student, which to me was shocking already. But now that it can, in some classes, right? Not in all classes. So I don't know. I mean, with the multimodal capability, I think it would do much better. But I know that in my department in aerospace engineering, it passed a PhD prelim exam, one PhD prelim exam. So anyway, it depends on the use case. Couple of other things. We are looking at generative AI and AI as a component of our long-term vision. We're also, I'm reading this from the report, and we've also made some steps towards initiating a multi-university research consortium. Maybe a bit more on that I might touch upon in the coming slides. And also, maybe this is a moonshot here, and we don't have the resources to do it, but at least we're thinking about, deploying foundation model type sandboxes for various departments sometime in the future, and especially kind of observe what happens when these models from different disciplines interact, right? So there may be something interesting coming. But all of this is dependent on large-scale computing resources, which none of us have. And we also started a scientific foundation models initiative. It's going to become a center, and Venkat is going to be leading that. All right, so now I have about 11 minutes. Some quick word about the conference. We have a wide variety of people. As soon as I finish speaking, this room will be full. So we have participation from around the globe and all over the US for sure. And it was a very good session yesterday, especially in the morning. All right, so as I mentioned, yesterday we saw drug discovery, biological systems, materials models, and also LLMs for theorem proving. And before we started, I talked about some potential capabilities that SciFMs can bring to the table in the near term and in the long term. And I think we already saw some of these being exercised yesterday, so that was pretty nice to see. And in fact, I was pleasantly surprised how far these groups have moved. If I had spoken to them 6 months ago, the story would be different. And the trajectory and the slope is what I'm looking at, and it's pretty impressive. So one other, before we move on, I want to ask a question. So what fraction of R&D in the US do you think is done by federal government, and what fraction by the industry? Can I get some numbers? The federal government contribution in 2023, roughly? What do people?
25%.
25? You're very well informed. Yeah, something like that, probably even less. Yeah. So I stole this from Jason's talk, and Jason is going to talk about this. So it was almost 20% as of 2020, and companies are really pushing their budgets up, right? So that is something to keep in mind, because at universities, that's really not the picture that we see. And the other thing is the landscape is changing so dramatically, right? So back in the 70s, the graph was completely flipped. And federal government R&D is also growing, but it's growing at a very slow pace compared to how industry is growing. Just to show you some numbers here. This is Google's annual R&D budget, which is probably 2 or 3 times NASA's entire budget, right? Including running the space station and things like that. So these are huge numbers. And if you follow the news, I showed this yesterday as well. Microsoft and OpenAI announced a $100 billion supercomputer. So in a sense, all of this is good news, because this is how research is supposed to work, right? So universities work on these far-off basic research things, and industry goes ahead and gets closer to the application. But a large fraction of basic research, especially in the topics that we're talking about, is being done in companies. So what is the role of national labs in this context? What is the role of universities in this context? It's easy to give a 1 or 2 word answer, but if we take the problem holistically, think about many things, including national security and sustainability, I think it puts us in a pretty interesting place. So, and I think we'll touch upon this in the panel, just something for you to think about. But I do want to say one thing, right? So yesterday when I started my brief remarks, I said scientific foundation models, if done well, and if we answer all the questions, I think they provide a framework for collaborative science that we always aspired to but never had, right? So think about, how scientific foundation models work, right? So that is data curation, data generation. That is this huge unsupervised pre-training stage, which at the moment only big companies can do, and maybe some national labs can do. And then there is a fine-tuning stage, which is making these actually useful. And then there is this probing thing where it's all not a one-way process. I think we have ways to look at the model, look at the outputs, and then answer questions about what the data should look like and what the architecture should look like. And of course, that is adaptation and downstream tasks. And I think universities are very well placed, at least it's my personal opinion, obviously to develop the methods and frameworks, the problem formulation, but also this particular angle, which is, we are creators, keepers, and transmitters of knowledge. So I think here as well as here, I think we have a very big role to play. And of course, in collaboration with labs and companies, I think we can have a big influence here as well. I wanted to show you something interesting along these lines, but I'm going to skip because I'm running out of time here. And then, as I mentioned, there are some very open questions at this point that stand unanswered, even given the enormous potential that we see from these foundation models. And I've listed some of them. We'll tackle these head-on in the panel that's coming in a couple of hours. I'll read out a few. Right, what are the scaling laws? What is emergence? There are very many definitions. I have my own favorite definition. And if I go by the definition, I'm actually more concerned that these models can't do anything deep, right? But it's something for us to think about, right? And yesterday morning, I was pretty excited, especially because I thought the 3 applications that were presented were almost sweet spot applications. They had some underlying discreteness. The tasks were modular. They had high quality data, and they were really making a lot of progress. But in many other problems, the objectives, inference objectives are ill-posed, abstract, misaligned. And these are problems that we care about very much. So again, what do we do there? Of course, there is the compute issue, generalizability, and of course, interaction with humans and human-type reasoning. And the second panel in the afternoon, or late afternoon, we're going to talk about the ecosystem that I spoke about, especially in this landscape where companies are dominating in terms of even basic research in certain aspects of foundation models, certainly on the compute side, and also being close to the application. So we also have a couple of venture capitalists who are going to be on the panel, and a few more that are going to be in the audience. So I look forward to a very interesting discussion. But mainly, I want to see, how can we organize ourselves better? Collaboration, generally at a university, inter-university level means we have a joint project. There are some faculty and students here. There are some faculty and students there. And we somehow come together and work and publish something. But maybe there is a way to reimagine how we operate, especially with these challenges when impact requires scale, right? Scale is almost the most important thing for impact here, which has not been the case in the past. Yes, I think we'll hear more about it in the panel. Maybe this is too detailed for this session. I'll just maybe wrap up showing you how the rest of the day is going to look like. So we have an emerging paradigm session where we have 3 speakers, and then we have the panel discussion. And I really encourage you to go to the East conference room where the second session was yesterday. We have about 20 to 25 posters, about half of them on foundation models, and some are really good. I mean, I should say all of them are really good. and the other half, which are also all really good, are on AI and computational science. And please enjoy your lunch while doing that. And then in the afternoon, we have a Frontiers of SciFM session. We have 3 talks. We have a coffee break. And then roughly we have 90 minutes kind of dedicated, starting with Jason Pruitt's talk, dedicated to the ecosystem, right? So how do we envision a future of collaborative science across industry, academia, and national labs? So that's going to be a pretty interesting discussion, and then we'll have some closing remarks and awards for the poster session. And I also want to thank Donaldson for sponsoring the poster session.